Hey, welcome back to Cambium Connections. I'm Maribel Lopez, and I'm thrilled to be back here with Vivek. Vibhu Vivek is the SVP of products at Cambium Networks, and his team has really been hard at work looking at all the different technologies and how do we advance and how do we make wireless work better. And one of the things that I think is on everybody's mind, I know it's on all the enterprises I talk to, it's on all the service providers I talk to. And that is the question of how will Wi-Fi 6 and 5G coexist? We've got a lot of wireless technologies out there. I think everybody's trying to say, hey, this one's better than that one, this one's going to kill that one. And the reality is it's not that simple. So I'm going to turn it over to Vibhu, and we're going to hear more about that. Vibhu, take it away.
Thank you for joining. 5G will replace Wi-Fi 6. This is not a new phenomena. Every time a new 3GPP standard is released, we talk about that replacing Wi-Fi. But this time it has got special attention. And there are primarily two reasons. Number one, because of COVID, connectivity has got special attention, and people are talking about such topics more. But there is another more important reason. If you look at Wi-Fi 6 and 5G, both have evolved and become more efficient. And they have done it by using the latest technologies and sometimes picking technologies from each other. So in turn, they have become very, very similar. The PHY layer has become very similar. So why shouldn't one replace the other? That's a very natural question. Look, your arm muscles and your leg muscles are made of very similar tissues. But both these muscles serve very different purpose. They're designed to do different things. And it's very similar in Wi-Fi 6 and 5G. So what we will do today is go through each of these standards, contrast them, compare them, and see what they are best suited for. So let's get into it. Which is better? We will compare them across various performance parameters and see how are they different. So number one is capacity. This is probably the most talked about characteristic. Look, both 5G and Wi-Fi 6 now support 1024 QAM, Mimo, OFDMA, and so the modem is very similar. So why shouldn't their speed be similar? The real difference lies in the frequency they operate on. Wi-Fi 6 operates on 5 to 7 gigahertz. 5G operates on mid, low, and high bands, going up to actually millimeter wave. In millimeter wave, you have lots of spectrum. That's why you can have bigger channels, much wider channels. In Wi-Fi, the channel size is limited to 80 megahertz. In 5G, you can have gigahertz channels. So that's why the capacity will be more when you're using millimeter wave. There is another reason why millimeter wave gives better performance, and that is MU-MIMO. The higher the MU-MIMO order, the larger the capacity. And to achieve higher order MU-MIMO, you need to form lots of narrow beam, which means you need an antenna which has a lot of patches, big array of antenna. In millimeter wave, the wavelength is smaller, so the patches are becoming smaller. They can be much densely packed. So you can, in a small space, you can form a very large array of antenna. Whereas in 5G, your 5 to 7 gigahertz spectrum, your wavelengths are longer, in several centimeters. So the patches become bigger. they cannot be packed together as closely, so the antennas become larger. So beyond 8 by 8 is not practical in most cases. Whereas in 5G with millimeter wave, you can go to 32 by 32, 64 by 64, or even larger. And that's why you can have higher order MU-MIMO and get more capacity. So look, 5G can deliver more capacity than Wi-Fi, but only when they are using millimeter wave. When they are in lower frequency, they are similar to Wi-Fi. Next is density. If you look at standard, they talk, both these standards use different verbiage to describe density. While Wi-Fi 6 will talk about 1,000 users per AP, thousands of users per AP, right? 5G talks about so many million devices per square kilometer, right? So because the purpose is very different. Wi-Fi density is optimized so that in a conference room, in a stadium, uh, in an arena, you can put in where the density is larger. People are next to each other. How many people you can serve through one AP? Whereas 5G is more WAN technology for wider area networks, serving many sensors on many phones in that network. That's what it's designed for. So it's different. Latency. Latency had always been an issue with 3GPP, right? Whereas 5G, with Wi-Fi, you could get a few millisecond latency, even in AC time frame, right? 5G has made a big leap. With 5G, particularly with URLLC, you can get sub-millisecond latency. So for normal applications, video, voice, AR, VR, both these standards can serve, no issues. But when it comes to uh, automation control, very highly reliable systems, 5G is the way to go. One, they are working in licensed frequency, that's why they're reliable. Extra protection for reliability there, and as well as they can get to some milliseconds. So when a very highly sensitive system, electric grid or automation control is needed, it is 5G URLLC is the better way to go. Range. Wi-Fi is a short distance protocol, right? You are talking about 100 meter, 200 meter, maybe 300 meters, but it is still for local area, whereas 5G can go for miles. It's a wider area. Of course, the distance of 5G depends on the frequency you're operating on. With millimeter wave, the distance is smaller, but it is still a long distance protocol. Virtualization, this has become very interesting. Some form of virtualization through passpoint has been there in Wi-Fi 6 for several years now. And what passpoint allows, that from one Wi-Fi access point, you can run multiple SSIDs belonging to different businesses, get all these businesses getting authenticated to different authentication system. In 5G, network slicing has taken it further. You can not only run different businesses, different authentication systems, but these different businesses can run very different type of data. One could be mission critical IoT type of system. The other could be voice. The third could be video or normal data services. So, and each of them, the network is sliced so that each of them work very efficiently. And that's something new in 5G. And that has brought in a private 5G networks in forefront, because from a service provider from one infrastructure can serve different type of businesses who have different types of needs. Lastly, battery life. Wi-Fi 6 battery life is optimized for phones. Your phones can run from hours to days to weeks, right? you can, or your laptops can run for weeks. Whereas 5G has some special things with MMTC. They target 10-year of battery life, where these for sensors, where these sensors are in a wide area, and these sensors are running over battery, and still can run over 10s of year. And so the optimization is very different and serving very different needs. One is more for IoT, another one is more for smartphones and laptops and those kind of devices. But if you look at it, the 5G seems to be very well suited for fixed wireless broadband. We have ever increasing need for speed, right? And Wi-Fi has caught up with it over time. Even during 11N or 11AC, the needs of LAN was pretty much served by the Wi-Fi. But there was no standard fixed wireless broadband which could match that speed. Right? There were proprietary solutions existing, but no standard. 5G has filled that gap. And let's see how. One, 5G can run on licensed, semi-licensed, or unlicensed spectrum. So depending on the reliability which you need in that network, you can run on unlicensed, licensed, or semi-licensed spectrum. Secondly, we talked about capacity. Because of millimeter wave, because of high data rate, because of higher order Mimo, you can get a lot of capacity, serving many of Wi-Fi access point or many of the LANs through 5G. And lastly, the network slicing which we talked about is ability to slice the network so that you can run different types of services in IoT mission critical IoT service, or a video surveillance service, or a normal data service out of the same infrastructure, whereby a service provider can use his infrastructure to and sell services to different type of businesses having different type of needs. And lastly, 5G costs are higher, but eventually it will come down, so that your CPE devices cost will come down as well, and that is needed for your fixed wireless broadband. So altogether, it kind of covers all the gaps which is needed for a efficient fixed wireless broadband. How about indoor? Question could be asked that if 5G is so efficient and has large capacity with millimeter wave, why can't the servers and the phones and the laptops inside the building directly connect to a public 5G? And here's the reason why. Millimeter wave has poor penetration. So from a tower or electric pole, when you're radiating millimeter wave, it does not go inside the building. When it reaches, the signal strength is very low or not existent, and that's why you will not get that high capacity when you are inside the building and using millimeter wave. Second, then you can ask the question, why can't the service provider deploy, or the telcos deploy the Wi-Fi small cells inside the building? Look, this can be done, but it's a challenging thing. Even in electricity, right? Your public buildings, the electric circuit is owned by the building owner and not the electric company, because it's difficult to maintain, difficult to deploy, and same applies here. Another way could be that you can have the private enterprises inside the building can deploy their own net 5G small cells. Possible. There is a lot of infrastructure in 5G standards to facilitate that. But 5G is been made for a carrier and it is complex. It's a complex architecture for a private entity to go and manage it, maintain it. Secondly, it becomes expensive because the private enterprises will have to go and buy these licensed spectrum. third, when you come from your cell phone and join inside your 5G network, and when you come outside the building, you have to roam to a public Wi-Fi, public 5G. So that roaming agreement needs to be made. Again, there are facilities to do that, but it all brings a lot more complexity. So it becomes challenging. And lastly, Wi-Fi is there inside the building, right? It is serving all the purpose beautifully. You have most of your gears on Wi-Fi, your laptop, your television, your refrigerator, everything is there on Wi-Fi. Why change it if it is working so nicely? So 5G getting indoor for high capacity will remain a challenge. It will not replace the LAN. How about Internet of Things? Again, uh, 5G is complex, Wi-Fi is easy, so the IoT networks will be easier to manage in Wi-Fi than in 5G. But when it comes to mission critical needs, uh, which, which requires extreme low latency, which requires extreme reliability, 5G is the better way to go because of their MMTC and URLLC protocols. It's a better way to go. Coverage, again, inside the building, HVAC systems and other things could run on Wi-Fi. But when you are talking about wide area networks, low power sensors, 5G has the ability to handle those kind of distances. Cost, today, Wi-Fi is much more cheaper than 5G, and the cost difference will come down. But still 5G will remain more expensive because it's working on licensed spectrum, and one has to buy this spectrum. And lastly, the battery life. For sensors, for LPWAN, 5G has done a lot of optimizations and carried forward the work done in NB-IoT. And you are talking about 10 years of battery life. So whereas for high capacity, high throughput type of devices is what Wi-Fi 6 has been optimized for. So when you're talking about sensors, tens of years of life, 5G is the better way to go. So let's look at the applications. Let's start with the indoor and outdoor extension, and we'll go one by one. For residential, you will continue to use your home routers, Wi-Fi routers. There is no need to change. It solves all the need. Why change it? It is not expensive. You're not, all the LAN uses, connection between your phone to your TV to your server at home, those are free. Why will you change it? But yes, your fixed wireless broadband, now you have an option to run your fixed wireless broadband through 5G. Retail and campus, which both have indoor and outdoor applications, again, for both indoor and outdoor, Wi-Fi will serve the need. 100, 200 meters, high density, classrooms, Wi-Fi is made for that and serves that need. It is low cost. You will not change that. When applicable, 5G will work as your backhaul. Next, carpeted enterprise. Carpeted enterprise, again, the LAN will remain on Wi-Fi 6. There is enough security built into Wi-Fi 6 for them to be feeling secure about it. You have so many devices out there, it is less expensive, so there's no need to change. For remote worker, when they are at home, they will use Wi-Fi. But when they go remote at third locations, 5G could be a choice. So LAN environment, I think, will remain pretty much Wi-Fi. But it's a different matter when it comes to WAN, wide area, industrial, mobile, mission critical applications, sensors, it will be 5G. When you're talking about trucks moving and providing feeds about how the perishable items are there inside the truck, it's the 5G. When you're talking about sensors in a city, it's working over LPWAN. It is 5G. or when it's fixed wireless broadband, it's 5G. So in summary, Wi-Fi will remain a LAN technology. Wi-Fi and as well as LAN extensions to outdoor campus environments, whereas 5G will be a good fixed wireless broadband technology. It will be a WAN technology. It will bring and actually usher uh, mission critical Internet of Things uh, very rapidly, and 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 the LP WANs very rapidly. We have ever increasing need of speed. Wi-Fi 6 has served that needs, and Wi-Fi has served these needs over the years very well. There is always a gap. There is no standard which for fixed wireless broadband. That was a gap. 5G fulfills that gap beautifully. So I think Wi-Fi 6 and 5G will be in live in happy union. Thank you.
Hey, welcome back. Thanks, Vibhu. I think you actually took on a question that a lot of us in the industry analyst world have been talking about for a long time, and I think that the temptation is always to kill a technology here or there, but it's good to see that we can have some things coexist. So the answer was, is it Wi-Fi 6 or 5G? Yes, it's both. That's great. Now, I am going to ask a polling question, but I wanted to remind everybody on the session right now that you can put your questions for Vibhu by going down to the bottom and adding them to the Q&A tab. It's much more engaging for everybody if you send in questions, so I'm looking forward to hearing what you have to ask for Vibhu. Now, but before we kick that off, I would like to launch a polling question. And the question is, which features in the access network is the most important? So we're going to push that poll right now. All right, so while we are waiting for the poll, why don't I just jump in with some questions? So we are actually seeing a lot of interest in terms of public networks versus private networks. I have a lot of clients, particularly in the IoT sector, that are starting to look at, or that have big industrial, I should say, use cases that are looking at possibly doing private networks. I know some of the service providers have been talking about what they want to do in building or out of building. It sounded like the whole private network thing wasn't going to work in your mind. Is that a fair assessment of that, or how do we think about private networks?
No, so, actually, on the contrary, I feel private networks will come. 5G will usher private networks more rapidly than it has been used. It has always been there, but it will bring it more. And you can see the ecosystem building around it. When anything has to come, the whole system builds around it. So let's look at the regulations, the spectrum regulations. We have had, CBRS, which allows you to get a spectrum at a much more level, because we are sharing the spectrum, so it becomes less expensive. There is a lot of talks coming where we are using a spectrum in a locally licensed spectrum, so the cost is less. So instead of a whole countrywide license. So the spectrum is becoming cheaper. So that brings private networks to be available. The needs are there, right? The needs are, you cannot have automation control, right? That will require a private network, right? You cannot depend on a countrywide network to do your automation, mission critical automation control. So the standard is evolving to do that. So depending on the need, the private networks will come. Where what I was trying to portray is, for regular LAN, Wi-Fi has been established, is doing well. The whole ecosystem is built. It has served the need. There is no need to change. But yes, at the right places, private networks will come, and more. It will come, strongly.
Can we spend a minute kind of digging a little bit into an in-building wireless concept, right? So, for example, I've got a lot of manufacturers and other folks that are looking at this, and they're talking about applications with robotics and visual processing and other things, and they're like, okay, we've struggled a little bit with Wi-Fi in the past. You know, should I be thinking about 5G? Like, how do I think about the wireless portfolio indoors for some environments that might have been noisy?
Mm-hmm. No, so Wi-Fi, the multiple technologies have been used for that thing, right? And standardization, I wouldn't say that standardization happened or one technology emerged as a leader. But when I look at 5G, 5G NR, it does seem to be in a standard which will be winner and will standardize this. Uh, the evolution of URLLC particularly makes it a very good technology, very good protocol to solve those needs. So and the needs are also increasing. You know, like in Cambium during COVID, all our labs were automated. People were working remotely, and that requires that your equipments, your automation is is happening, right? You have a system to do that, reliable system to do that, and then 5G will usher that, particularly with where latency becomes important, reliability becomes important. 5G will usher that.
I'm actually excited that we have some flexibility around latency, because I think one of the things that we're going to see in 2021 and moving forward is this concept of people are going to think more about the latency of the application and what they're going to be able to do as a result of having different latency characteristics available. I think at this point, the poll has probably closed. Can we show the poll results? Waiting with bated breath here. We got reliability. We've got TCO. Any surprises to you here, Vibhu?
No, I think it probably maps to the type of business people are in, right? If you are a WISP, I think probably capacity and total cost of ownership becomes the most important, right? If you are a automation control, then your latency and doing a lot of videos, then latency becomes important, right? So I'm not surprised, but reliability is the key, so that wins. So I'm not at all surprised. It looks exactly right. I would rate reliability to be 1. Network is blood and life right now, and followed by the capacity, ever increasing capacity needs. We have seen that. Everybody has seen that how important it became during COVID, and when we are working at home, the broadband needs were increasing, and then we saw that need. So I totally see this is important. And while latency is not there, I can see that too. Is the last. Is most applications today, the latencies are good enough for broadband latency, or for that, are good enough. Wi-Fi latency has been good enough for a while, so latency has not been an issue. It's latency thing only comes into play when you are doing a lot of voice. More than that, I think when you will get into automation control. So I see that as the last. So I totally agree. It's exactly how I would have rated.
Yeah, and it's interesting because the automation control and the video a lot of times are coming together. So like
yes.
earlier, some of the other sessions, we've got a lot of video that's happening. And there's, well, actually, thank you for answering the poll to the audience. And I do have a question I wanted to pull in from the audience. I see 5G as a cell carrier technology set, and I run an enterprise network. While I understand the benefits for users outside my buildings and campuses, I need to be able to control the user's access inside. Wi-Fi solutions seem to be the way forward for me, or will Cambium deliver 5G for enterprise internal use?
So, will Cambium deliver?
Will,
So first of all, what you said, I agree with. It's a good observation. I am in line with that observation that that inside the network, inside the building, less use of, for normal purposes, there is less use of Wi-Fi, 5G. Wi-Fi is serving the need. There is not much need, as we talked about. Now, 5G does, in standard, 5G does provide you ability to segregate your network as you do in Wi-Fi. It will allow you, but it will come at a cost. It will come at a complexity. So why would you change? unless there is a specific need which comes, right? And those special cases are there, and we can discuss that, and we have discussed it. But normal situations, it will remain a LAN WAN technology, right? 5G will become WAN, and your LAN will be Wi-Fi.
Yeah. Okay. That's what that makes a lot of sense. It actually leads me to a quick follow-on question that I had in my mind. When we think about outdoors, how should enterprises consider defining when to use Wi-Fi versus 5G for outdoor deployments?
Sure. So outdoor is in many ways not much different. The determining factor is going to be cost. So if you're a campus environment, right, half a kilometer campus, or 1 kilometer by 1 kilometer campus, 2 kilometer, 4 kilometers, these kind of things can be covered by Wi-Fi and has been covered by Wi-Fi. School campus, university campuses, they have been, right? And it has worked beautifully. So why would you change it? Once you bring 5G, yes, when you bring 5G, and if you make it a private network, now you have to think about, one, you're bringing a complex network, 5G network, you have to maintain it. Even if the CSPs goes and provides that, then it will come at a cost. So there are many reasons why we would like to avoid it, but there will be a specific needs in outdoor environment. Suppose if it's a citywide sensor networks, right, or electric smart grid, yeah, 5G is the way to go, because your latency, your reliability becomes more important.
Great. Thank you, Vibhu. At this point, we're going to take a short break and give you some time to stretch your legs and check your email and do whatever you need to do. Please come back and join us at 15 past the hour for the next presentation from Scott Imhoff on The Time Has Come for 6 gigahertz and Wi-Fi 6E. But in the meantime, please enjoy this short video on wireless education solutions from Cambium. And a reminder, the link to join Scott's presentation at 15 past the hour is below. You have to click on that. It just won't keep auto rolling. Thank you again, and I will turn it over to the team for the video.
Thank you.